The recent loss of the Nealon's Gospel family band in a PC-12 accident following a autopilot disconnect while entering an area of convective turbulence follows a trend in the PC-12 community that deserves a second look. Let's check it out. If we take a brief look back at the history of the PC-12, this article comes from the Used Aircraft Guide published in 2019. Back in 2019, there were already 6 different PC-12 accidents that were the result of loss of control of the aircraft in IMC conditions. Most of these cases were preceded by the autopilot disconnecting and then the pilot losing control of the aircraft in instrument meteorological conditions. So I think it's important to review the limitations of the autopilot on board the PC-12, very similar to many other aircraft, because when the autopilot disconnects, and if you're a single pilot operation in IMC conditions, you could be faced with a very daunting task, especially if you are not particularly comfortable, current, or qualified to hand fly the aircraft in instrument meteorological conditions. So why are these autopilots disconnecting, and why are some single pilot crews having an especially hard time managing the aircraft and re-engaging the automation once the autopilot has suddenly and surprisingly kicked off on you? And if we go back and look at this NTSB report from an accident back in 2017 regarding a PC-12 in a Part 135 air taxi commuter accident situation, they give a good breakdown of some of the limitations of the PC-12 autopilot. Now, some of these limitations may change based on exactly which make and model of Pilatus PC-12 you're flying. The NTSB probable cause from this 2017 accident was the pilot's loss of airplane control due to spatial disorientation during the initial climb after takeoff in night instrument meteorological conditions and moderate turbulence. And this was preceded by an autopilot disconnect. On the PC-12, you control the autopilot, the mode of the autopilot, using this panel up here. Here on your flat screen display, the results of what you put into the autopilot are displayed up here in the upper portion of your flat screen display, telling you exactly what mode the autopilot is in. And here on the yoke are a series of buttons that help you manage the autopilot. And especially important is the big red autopilot disconnect button located right here. Next to the big red autopilot disconnect button is a trim switch. You engage the autopilot on the PC-12 by pushing the autopilot button located right here on the flight guidance control panel, as long as the aircraft is within limits for the autopilot. The autopilot will engage. You can disengage the autopilot by pushing this autopilot button again, or by pressing the big red autopilot disconnect button located on the left side of the yoke. The PC-12 also has a trim trigger on the control wheel where if you want to temporarily disconnect the autopilot and manually retrim the aircraft, that'll allow you to do that without completely disconnecting the autopilot and yaw damper. So if you pull in the trim trigger, the autopilot is temporarily off, the yaw damper remains engaged, you can trim the aircraft and then release the trigger and the autopilot is back on. This is important because on most any airplane, if you attempt to manually trim the aircraft with the autopilot engaged, the autopilot will disconnect. The autopilot will also disconnect if the trim interrupt switch is pushed. That's the button you push in the event of a runaway trim to stop the trim from moving. That'll disconnect the autopilot. Or if the alternate stabilizer trim switch is set to up or down, that'll kick off the autopilot. A loss of power to the autopilot computer or the trim adapter occurs. That'll kick it off. The monitors within the autopilot computer detect a failure, or the following autopilot monitor limits are exceeded. But there's one additional thing that'll kick off the autopilot guaranteed every time that's not mentioned in this list, and that is if you stall the aircraft, even briefly. So these are the limits of the autopilot. If you have a roll rate greater than 10 degrees per second, the autopilot will disconnect and it will not reconnect. Pitch rates more than 5 degrees per second, or accelerations outside of a plus 1.6 G, or I think that's supposed to be a negative 0.3 G envelope. So if you get, this is where the autopilot kicks off in turbulence. If you get into turbulence and you exceed these G limits, which is quite easy to do in turbulence, the autopilot will kick off. Now, if you get yourself disoriented and start maneuvering the aircraft a lot outside of these limits, the autopilot will not re-engage. The PC-12 has 2 angle of attack vanes located, one on each wing. Unlike Boeing 737, cut. The PC-12 has 2 independent angle of attack vanes located, one on each wing. When both of these angle of attack indicators agree that you have exceeded the critical angle of attack of the aircraft, it will sense the stall and tell you that the aircraft is stalling. If the aircraft enters a stalled condition, even if temporarily, for example, in turbulent air conditions, the autopilot will disconnect. Normally, if you want to climb up to altitude in the PC-12, you set your altitude in the altitude window here, and then you engage the speed mode of the autopilot, which is similar to flight level change for you Boeing guys. And then the aircraft will hold that speed, and you select a speed that's normally 20 or more knots above your best rate of climb speed to give you a good buffer from a stall margin while you're climbing. And you set your power, and it'll give you whatever rate of climb you can get at that power setting to hold that speed and give you speed protection. But in turbulent air conditions, you can get a gust of wind or a brief wind shear that even at that speed, you can briefly exceed the critical angle of attack of the wing, especially if you're heavyweight, because you're heavyweight climbing out, you're already fairly close to the critical angle of attack. You hit a good gust of wind and you can temporarily, briefly stall the aircraft, and the autopilot will kick off. And it can be a cacophony of events in the cockpit. You can hear stall, 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 and then autopilot disconnect, and then the associated autopilot disconnect warnings. Now, this condition where it just hits you suddenly and then the aircraft recovers very quickly is not enough of a stall to engage the other systems on board the PC-12, which include a stick shaker and a stick pusher. But it will disconnect the autopilot, and if you're single pilot, IFR, and not really up on your instrument meteorological conditions flying skills, this can be a very surprising and disconcerting situation. Because when the autopilot disconnects, these are some of the different warnings you're going to get in the cockpit. The CAWS system they mention here, CAWS, is the Central Advisory Warning System. So on the mode controller, the autopilot caption flashes 4 times and turns off. On the CAWS display unit, the amber autopilot disengage message illuminates for 3 seconds. And on the EADI, the red autopilot caption flashes 5 times, then turns off. And the autopilot disconnect warning tone is enunciated in the loudspeakers and the headsets. And the CAWS gong warning tone is also enunciated. So suddenly the cockpit is kind of lit up like a Christmas tree, and all sorts of warnings are going off. And the only way to turn all these warnings off is you got to reach up and hit the autopilot disconnect button to turn all this stuff off. So aviate, navigate, communicate. The first thing you got to do is jump on the gauges and fly the airplane. And disregard all these warnings for a second, because you know what it is. You should know what it is. The autopilot disconnected, but it surprised you in this particular situation. So the next thing you're going to need to know through your training is to turn all that racket off by hitting the red autopilot disconnect button on the yoke. Now, once you get the aircraft under control with a known pitch and power setting and the autopilot warnings all turned off, now you can go about re-engaging the autopilot as long as you're within limits of the autopilot limitations and continue on with the flight. But if you begin to struggle with wondering what is going on with your automation, if all of these warnings are throwing you for a loop, you can quickly and easily begin to lose control of the aircraft if you fail to fly the aircraft first. And if you're a private pilot or a commercial pilot that is transitioning for the first time to something as big and complicated as the PC-12, this is why you need to go to school, a professional training program, maintain a professional training program every year to remain current and proficient in this complicated level of an aircraft. Talking to my friend Jerry Clemens of Clemens Aviation Insurance, He requires that if you're going to own one of these PC-12s, that you're going to have to attend formal training in either SimCom or flight safety. And if you're a relatively low-time pilot, you're going to need to fly with a mentor pilot for 150 to 200 hours, an experienced rated pilot in the PC-12 in all sorts of conditions before you get very familiar with the flat panel display and the management of the automation in this aircraft. And as my friend Hoover said in his 17-minute video on the Nealon's plane crash, if you can afford something like a PC-12, at least you can afford a second pilot to fly with you or a professional pilot to fly the aircraft for you. Thank you so much for your support of this channel, especially the folks over on Patreon that make this content possible. See you here.